So we've got that part wrapped up, so I'm going to go ahead and get into introducing Sandi. Sandi is an awesome person. I was really excited when, or the organizer was really excited when we got to line her up as a speaker tonight. She recently, as you know, she's an avid biker and cross-country skier too. I did not know that about her. That's really awesome. She's recently spoken at Goads Gotham Ruby Conference. That's in New York, right? Yeah. She works with Duke University. I'm not 100% sure what she works with, but I'm sure that it's really technical stuff. I've been told it has something to do with programming, but I'm not sure. Last month she was on Ruby Roads. That was a really great podcast. She's from Durham, and she recently spoke at Rocky Mountain Ruby Conference, right?
I've been traveling a lot.
She's been traveling a lot. Okay, cool. So, and she's recently written a book, and I forgot the title. Hooter. Yes, I'm so sorry. Here it is. Practical Object-Oriented Design in Ruby. I haven't read this book yet, I can't attest to it, but everyone and my fellow organizers have told me that it is pretty excellent. So, like up there with Eloquent Ruby, like you gotta own this book. So I'm gonna be buying this ASAP. So then I can do that. So, and without further ado, Sandi.
Sandi, party drop, come on.
Can you hear me?
Pretty well.
Pretty well. I'm standing right next to the thing. I can't wander very far from the speaker.
Yeah.
So I'm just going to yell.
Yes.
So I'm Sandi Metz. Some of you know me, all the Durhamites know me. I used to go to West End Ruby over in Durham, and you're all welcome to join us over there. We drink beer. It's a small show. So sign up quick if you want to come. And tonight I'm going to talk about object-oriented design. Obviously, it's a big topic in the community right now, and I'm really exposed, so that's why I'm here. But before I talk about design, I'm going to tell you a story. You probably know this story. You love your life. You love Ruby. You love Rails. And you wrote an amazing app. And everyone thinks you're a genius. And then one of your customers asks for a little change. Just a little change. You say, yeah, you check out the code, you put in your text editor, you make a few changes in it. Turns out you have to make a few more changes and maybe a few more, and the tests are a little bit broken, you get them all working. And you check the code in and you deploy it to production. And then it turns out they didn't really want that. They want this other thing instead. And so, okay, you check the code out, you put in your text editor, you make a few changes, you make a few more changes, you make a bunch more changes. Now a lot of tests are broken, and it turns out this isn't as much fun as you had hoped it might be. But you get working, you check it all and you deploy it. And then time passes and they ask for a new feature. And now, everyone's insane, their hair's on fire, like they gotta have it today. It has to be done right now. And you look at the app and it just was not designed to do this. And what you do is it's like being in the jungle, right? You get a machete out and you just whack your way through the application, making changes. And at some point, you begin to wonder whether it's possible to check code in without putting your name on it. And you realize, one day you wake up and you realize that you hate this app, and that you hate Rails, and you hate Ruby, and you hate your life. You know this story. In the beginning, the app was a delight. You felt great because you were getting so much done. And that feeling of deep satisfaction you get from your first Rails app was because of how efficient and effective it made you feel. We feel happy when we're doing our best work. And these feelings stand as proxy for the state of our apps. But unfortunately for many apps, this feeling peaks right about the time when you release the first beta. And then it goes down the things get worse and worse. You were fast, now you're slow. You were happy, now you're sad. You were cost effective, and now you're a money pit. The app was amazing, and now it's just a mess. This does not mean that it's time to look for a new job. Unless you change something, you'll end up hating every have to ever write. These applications are prisoners of their designs and they've taken you hostage. You cannot outrun this problem. You have to do something different. You have to learn to understand the mess. And the problem with messes is, of course, that they're messy. They're hard to understand. Everything is tangled up together. They're like big tapestries. The warp and the weft are woven inside and out there. Everything is coupled together. In the beginning, everything is idyllic. But as soon as you start making changes, that illusion gets shattered. Your app is not a pastoral scene with cute furry little lambs. No, your app is trying to kill you. Things are so woven together that you can't pull on any single thread without breaking many things. And this coupling, this mess, is because of knowledge. Knowledge. Your app is made of objects, and objects know things. They always know things about themselves, and sometimes they know things about others. And it is knowledge of others that weaves the objects together. When an object knows something outside itself, that's a dependency. We all know about dependencies. Dependencies are something where if something that you depend on changes, you might be forced to change in turn. You cannot avoid dependencies. Objects have to collaborate. And these collaborations require that they know things about one another. However, there are many different ways to solve any programming problem, and you can easily arrange your dependencies so that things turn out badly. Controlling dependencies requires understanding the stability of the various bits of knowledge in your app. Everything any object knows can be ranked along a continuum, like really stable things on one end and really unstable things on the other. And it turns out it doesn't actually matter how stable any individual item is, it just needs to be more stable than the things that depend upon it. Things that are, stability is relative, and things that are wildly unstable from some points of view are perfectly reliable from others. It's also true that sometimes you don't know. You're confused. Who does that? You're confused. You're confused about the relative stability of the object, so you don't know what you can safely depend on. And this is where object-oriented design gives us hope. Object-oriented design is the ultimate dispenser of programming treats. Hope. Object-oriented design lets you write code that your future self will love, even in the face of confusion and instability. It knows how to separate the stable from the unstable, and it can show you how to depend on the first and hide the second. It gives you a way to manage the mess so that you can write apps that are efficient and fun forever. It changes everything. It lets you stop worrying and learn to love the mess. Okay, that took however many minutes it took. I don't know why it says that. I'll tell you what. So now I got 10 more minutes. Actually, in the next 15 minutes, I'm going to show you a miracle. I'm going to show you a miracle of object-oriented design. I'm going to convince you that if you learn a little about design, you can love your life and you can fix your apps. So the example is going to be in 3 parts. The first part is just going to be set up. I'm going to show you some code. And then I'm going to make a change to it that's going to make everything a wreck. And then we're going to fix it. We're going to isolate the instability and change the mess. There's an arc to the examples of this talk. And here's how it goes. Concrete code is easy to understand and difficult to change. One big object that's a long script, you can tell what it does, but you cannot change it. You cannot reuse that code. Abstract code, a lot of little objects that interact, are much more difficult and you cannot look at the parts and immediately understand the workings of the whole. But that's code that you can change. The principles of object-oriented design move your code along the scale from more concrete toward more abstract. And if you know those principles, you can choose the point at which you can stop to maximize your benefits, to give you the most changeability and the most understandability based on the arrangement of the code you have. So, example number 1. We have a game where players race bikes. Bikes have shocks, players have to buy shocks. And so before they buy a shock, they want to know what it costs. The customer. Well, let's just look at it. So somebody sends a shock cost message to game, it forwards that on the shock. Here's shocks, implemented shock. The shock classic has this implementation of cost, which is so ugly that I didn't even write the code. This is a huge, big, ugly mess. Now, even though you can't see this code, let's make an assumption of that. Let's assume it has these qualities. It has no dependence. That means that nothing in it can change that would force a change any place else in your app. And it has no dependencies. There's nothing out in the rest of your app that can change that would force a change here. I'm going to call that kind of mess. It's a special kind of mess, and I'm going to give it a name. I'm going to call it a mega mess. And so mega messes are the end of the line, and they have no dependence and no dependencies. And the question we always have at this point, so I have this big, ugly, embarrassing file of code. What should I do? Should I leave it? Should I change it? That's the fundamental question of this talk, and I'm just going to pose it and leave it for a minute. First, I want to look at this a different way. Who knows what this is? Yell it out.
Sequence diagram.
Who's never seen one before? If you've never seen one. Okay. So this is a picture of the objects and the messages that pass between them. It's a sequence diagram. It's UML. I know that's a curse word. It's UML. But trust me, it'll be okay. Here's how sequence diagrams work. The objects are in boxes. An object can be an instance of a class or a class itself. They're all objects, I don't care. Those are repeated at the top and the bottom of this diagram, and they're attached to this line. When a message gets sent, there's a solid horizontal line. This line represents a player sending the shop cost message to an instance. The filled-in triangle on the receiver side, this vertical gray bar says that game is busy processing shot costs, and the dash horizontal is the result of that. I use I use web sequence diagrams to draw these. It's a nice online tool that makes it easy to get a picture. I use sequence diagrams all the time. Here's how I do them. I scribble them on the whiteboard. The woman I pair with very often, Lori Evans, is here. And we spend a lot of time just drawing on the whiteboard, erasing and drawing, and then we just erase the whole thing. Or actually, I leave it there so we have to chisel it off until the last one. They're really great as transient tools to figure out what messages you want to send. I never do anything this formal unless I'm giving a talk or I have to write a book. So don't feel intimidated by the fact that it's UML. This is the best way to think about objects. And you would all be, it would improve your life if you got comfortable using this diagram. I'm going to write on it. I'm going to put some other markers on it. So I'm going to draw an arrow for an object's knowledge that's knowledge about something that's external to it. And I'm going to use this other shape for knowledge that an object is internal to an object. I'm going to mark the stability with this color code, which is like a stoplight. So red is unstable and green is very stable. So in the source code, you probably, and I know you're not used to looking at sequence diagrams, so you'll probably have to try and remember what the source code looked like to understand it. The game knew the name of the shot class. It knew that that object was the new message. It knew that it was going to send, it knew the name of the cost method. It knew that it was going to send that message somewhere. It knew that it was going to send it to the thing that it got back from, say, new to the shop class. This is a ton of things. Shop knows that it implements the cost message, and it knows how it does so. So what you can see here is that game depends on a bunch of things outside itself, but shop doesn't. Shop's at the end of the line. Shop doesn't have the extra dependencies. This picture, this sequence diagram is a much truer representation of the application than the code. In the code, the big mega mess is probably huge. It dominates the listing that you see when you look at it. But in the sequence diagram, it's reduced to this little gray bar. From outside of shop, all you need to know is that you can send that message. The mess is hidden behind that message. So this view of reality is deceiving because we have this feeling, as programmers, we have this feeling that pounds of code somehow equates to importance. And it probably ought to be true. It probably ought to be true that the amount of code I look at, like the big file of code ought to have a lot of importance and a little file of code ought to not be so important. But the truth is here, this method is like a big, drunken, boisterous guy at a party holding forth in a room surrounded by geeky introverts. Like, this is not the most important thing, but it's hard to see anything else when you walk into this room. So, do not be misled. It's not about the code. It's not about those classes that are defined by the characters that you typed into those files on the disk. It's about the running, living, breathing objects as they interact in memory. It's about that message. And so now we've looked at the code. I'm just going to jump up to 10,000 feet for a second and put that plot in the model. So this is a little plot where stability runs left and right. This is within and outside of my purpose. The my is the object that we're talking about here. So something that is part of my responsibility that would be completely inside my purpose would be at the top. Stuff that's outside my purpose would be at the bottom. The top left-hand corner of this quadrant, public things, stable things that are within your purpose should make up your public API. Unstable things that are within your purpose are private behavior. You need to implement that behavior, but you should hide it. Anything below the line is a dependency. You should expose the public API, hide your private behavior. Now, objects have to collaborate in order to get things done. You cannot avoid objects knowing about each other. But you should, minimize, you should only be dependent on stable things, and you should minimize the number of dependencies that you have. This stuff that falls into this quadrant, unstable dependencies that are outside your responsibility, when your applications are making your life a living hell, because every time you reach in and grab a thread and pull it, everything breaks. It's code that belongs in this quadrant. Unstable dependencies that are outside of your responsibility. So let's put the stuff we know on this plot. So we said that shock knows the name of the cost method and its implementation. Name depends on the name of the message, the name of the shock class, and the category receiver of cost. I'm just going to get rid of game for right now because we're not really going to talk about it much more. But so let's take these two things, the cost method. The name of the cost method, shock has an obligation. Shock is responsible for answering to cost. This is about as stable as it can be. That method, the name of that method is not going to change. Other objects can rely on it. However, the implementation is wildly unstable. And as a matter of fact, I can't remember whether I told you this when we started, but the customer of this game has already told us that they know the calculation is wrong. And they've told us that they're probably going to have whatever shock codes. But this is all they do. This is all they can tell us right now. And so we understand that the implementation is not only is it a mess, but it's probably not even right. It's pretty much guaranteed to change. But it doesn't matter, we're just going to hide it. It belongs, we're going to hide it behind our public message. So there we go, example one. The 10 lines of code. Not counting the mess, I've been talking about it 10 minutes. So earlier I asked you to ponder the consequences of walking away right now, of leaving the code in this state. Is it worthwhile to make any change here? But we know the cost method is going to change, we know we need to get more, but we don't know how. And so at this point, you ask one very basic question. What is the future cost of doing nothing now? You will always have better information in the future. The Yagi guys put it perfectly saying, you will never know less than now. If it will not cost you money to wait, you should do so. The most cost-effective strategy is very often to do nothing. And this is a case where it won't cost you money. It probably won't cost you money to wait. The Omega mess has no dependence and no dependencies, so you can leave it without consequences. Now, having said that, if this code were mine, I would do a few things before I left it. I would inject that dependency, and I would refactor this code into a bunch of small methods with intention of being names. You might not. I do this because I do these things almost without exception because doing the refactoring that simplifies code is like buying a ticket in a lottery that's rigged in your favor. This pays off so often that your best strategy is to play every chance you get. I don't think of this as design. I think of this as the thing I do, the last thing I do before I hit send on the email. When I skim through it and make sure that the spell checker didn't substitute any embarrassing word, or I didn't make a typo, right? That kind of needing to make code easier to look at, easier to reason about, is something that I would suggest that you do all the time. but I don't think of it as design. So there we go, example one. So now let's make things interesting. Let's introduce a complication. So the game's a big success. Customer came back and told you, okay, I want 4 different shock types. We're going to introduce more shocks that have different characteristics, and they'll have different prices. Later, when you see lefty for a front shock, you know what it is. So I gave a sample of this talk to some people who thought I was talking about electricity. So there's a lot of different shock types. Don't worry about the names. So some well-intentioned programmer has gone in and made a change. They introduced this type. Now in the GUI, the player picks the type, and it gets passed in here, and now it just gets forwarded onto the shock. So let's go look at what happened to shock. Well, it's got a reader, and it takes that type when it's initialized. But the interesting thing is, the cost method now contains a case statement that switches on type to get the right calculation. You see it all the time? Tell me you've never seen this. So now I have 4 calculations here, and each one of them is a big mess. There's a sequence diagram for this code. And I told you before that sequence diagrams were a better representation of reality than in source code. But there are programming sins you can commit that are invisible on sequence diagrams, and that case statement is one of them. Except for this, that, and this, and I just put a note on it. Other than that, the sequence diagram looks identical to the one before. You cannot tell by looking at it that I have ruined a perfectly good megamess. Right? It used to not have dependence. Megamesses don't have dependence or dependencies. And is that still true about this code? Well, let's have a look. It used to know just one cost calculation, and now it knows 4. And now it also knows 4 shock types, and it knows the mappings in between the 2. These things are known to, but not owned by, shock. What will happen if the application has a shock type? What will happen if it removes one? What will happen if any one of these calculations need to change? Suddenly, there are many ways in which the rest of the app could change that would force you to make changes in this method. The case statement caused an explosion of dependencies. It's no longer, that case statement is not a mega mess. It's something I'm going to call meta-knowledge. And meta-knowledge is knowledge about knowledge. The mega messes are hidden inside the pieces of the puzzle. And meta-knowledge is about how the puzzle fits together. Object-oriented design deals with meta-knowledge. It can explain what just happened. It understands that this explosion of dependencies, and it offers you many different ways to deal with it. And in a minute example, think of a miracle will occur. I'll show you just one of them. But first, before we do that, let's jump back up and put this stuff on the fly. So we already dealt with the cost method, and it's still up in the upper left-hand quadrant. The 4 shock cost calculations. So when shock calculated its own cost, that was clearly its own responsibility. But now that there are 4 calculations, is this still shock's job? Knowing about 1 was okay, but knowing about 4 probably belongs somewhere else. These calculations are not about shock. They're about a bunch of different shocks. This is not shock's job. And we should move that knowledge. That we've introduced a bunch of instability here that's going to make this thing costly to change. So how about the fact that it knows 4 types? Well, it's the same problem. There's 4. This is equally unstable. It's just as unstable, and it's clearly not shock's job. The mapping between the types of calculations is probably more stable, but it clearly doesn't belong in the object where it is. These new dependencies are what make this code costly to change. The method used to be independent, and now it's interwoven into the rest of the app. And it's not only costly to change, it's likely to change. Once you get 4-ness, someday you're going to have 3-ness or 5-ness. adding that case statement in the Metz. And it's really unfortunate because this problem is completely avoidable. You do not have to accept these dependencies. You can easily arrange the code to take them out. It just takes a little bit of knowledge. And here's the guiding principle. We would rather send a message than implement behavior. I don't want to know things. I just want to send a message to an object. Okay, well that's a great theory, but here the problem is we don't have an object. Shop was at the end of the line. It already knew how to calculate cost. And when we asked the question, where should I put this new code? The only place we had to put it was in that existing cost method. It seemed like the obvious place. But that's the wrong point of view, and it's because it asks the wrong question. We acquired these dependencies when we ask what object should know this. And we can remove them now by asking, what message should I send? Now, I know that's a hard question to ask because we don't have anybody to send it to. But I don't care. We're going to ask about the message first. And if it turns out we don't have anyone to send it, we will make up an object to send that message. So that brings us to example 3. Composition. Object-oriented composition. It's one of those great words that you read about in those books that are so hard to read. Not mine. I would explain it, but it's easier just to show you. So here's the code. We have this big other case statement. We want to reduce the dependencies. We would rather send a message than implement behavior. We don't want to know things. We just want to ask them. So there's a repeating pattern here where we switch on site and go to the Metz. So let's just look at the first one, the one we had to start with. I don't want to know this calculation. I just want to send a message. Well, what message should I send? Well, I don't know. How about repeat? That'll work. So now that I've decided on the message, well, where am I going to send it? Well, let's just make something up. I'll just make up a class. I'm going to take the name of the type, the symbol of the type, and concatenate it with something. I'm going to make a new class. I'm going to implement the compute method in that class, and I'm just going to move the entire contents of this method and put it here. Do you recognize this? That's my megamess. I got back to where I had the megamess. It has no dependence and no dependencies. So now that we have someone to ask, we can just send a message. And I can do that over and over again for each one of these. I can make up a new class, each one of which contains a megamess. And then I get here, and I have composition. Shock is now composed of all these shock constructs. But somehow this code is just not very satisfying, is it? I mean, this is the reaction people always have when we get here. Really? And I think the reason we don't do these refactorings as a community is because we can only see to here, and this does not seem like an improvement. That case statement still inflicts many dependencies, and on top of that, now I have 4 new classes. Now, at the beginning, I said object-oriented design moves your code along the scale from more concrete, more procedurally concrete, easily understood, to more abstract, where you have a bunch of little objects. One of the complaints that you hear when people say, oh, I don't really want to do it because I have a bunch of little objects. And so here, like, is this an improvement, or did I just complicate things in the name of design? What does this accomplish? Is there any improvement here? Well, actually, there is, a little bit. Shock used to know 4 shock cost calculations, and now knows the name of 4 classes. It used to know what type got what calculation, and now knows what type is what class. So there is good news here. Now we've reproduced all those megamesses. Every calculation is by itself, so you can test it independently. You can edit it without breaking other things. But there's still bad news here. I have an enormous number of dependencies that are embodied in the meta-knowledge that's contained in that case statement. There are plenty of things out in the rest of the app that can still change it and force this code to change. If you add or remove a shock, you have to change this method. I hate it. So let's just fix it. Notice the pattern. I'm switching on a symbol and getting a class name. It's like front shock classes are like foo shock class. Well, I control these names, and I'm a Rails programmer, and I really love the whole idea of convention over configuration. Let's do a very Rails-like thing and use a convention to manufacture the name of this class. I can get a string that contains the name of the class I want. That's easy. Now you have to control the names in order to do this. And there are a bunch of other things you can do. And in this case, this is the simplest kind of thing. I'm going to build a string with a class name in it. And then I'm going to ask somebody. Now I know that every really good Ruby programmer here is shuddering right now, so hang on. I can take a string and invoke Ruby and have it return. If I have a string that contains a class name, I can invoke Ruby any object back. Now this is arguably the worst possible way to do it. Okay, so don't do that. But it's the most straightforward example to do. Really, this is what the Ruby guys want you to do. So it's like every object, every class that exists in Ruby, like there's somewhere, right? When you mention a class, it's a constant, it's on the list. There's like a hash table somewhere. I don't know what it is, but you can think of it like that. It will work, right? So you can look up the name of the class. You can ask object constant to look at the name of the class, and this returns the class. Now, if you're a Rails program, which you probably are because you're using the title of this, Rails is monkey patch string to add this constantize method. So if you have a string that contains the name of a class, you can send constantize to that string, and you'll get the class name. And then you can say new to it. Any one of these things works. You should probably be doing the second one if you're a straightforward Ruby programmer. You should use the third one, use constantize for your Rails program. So this is a tiny, tiny, tiny little bit of method. And we're going to use it to manufacture a class. Now, I use the word manufacture quite deliberately. It's exactly right. Here's this is a factory. Now, I know some of you like, even now I'm using that factory word, breaking this way, because you came from those languages where everything was hard. You have been clever enough to pick Ruby, and those days are over. We love factories. Not only do we like factories, but we love this word. There is no other word as good. And I want to be able to use this word without people feeling bad. Something that manufactures an object is a factory. It's as simple as that. There's nothing hard about it. And so now, I can remove the entire case statement. And the cost method no longer needs to know the names of the four classes. It doesn't need to know the name, it doesn't need to know the types, it doesn't need to know the mappings between them. It just needs to know the convention. So I can change this code to this with all these little classes. It's a huge win. I can delete a shop without changing anything but removing that one class. I can add a new shop by following the naming convention and just putting a new one in the application. Yeah, I would like to do that. So, and that's composition. That's all there is to it. So when you move your code along the scale of like one lumping procedure to a lot of little objects, when you get more into, when you drive yourself more to abstraction and get small, tiny objects that you can talk to, what you find very often is the problem changes to one of getting the right object, picking the right one of those, which means that you have to be comfortable with the idea of factors. You have to be comfortable with the idea of manufacturing an object whose class you may not know, and trusting it to do the thing you want it to do. I find it's so hard to talk about these things that I drew a picture, so we'll see how this goes. So, give me some feedback later about it. This is the shop class. It used to have that one cost method in it, and we jammed 4 shop calculations in there. This is how you refactor from this case statement, from the Metz into composition. We pull all the methods out, we wrapped them in classes, we picked a message, we taught shop to send a message, and we made every one of those guys implement. As soon as we do that, the class of the object disappears. It doesn't matter. It only needs to implement that interface. And the way I make it do it is I just teach it that message. This message, the message defines the API of a duck type, a role. Shop's cost method doesn't know or care about the class of the object to which it's sending a message. It expects every collaborator to simply play that role. And when you start thinking of collaborators as a kind of their role, rather than a kind of their class, it changes everything. You can manufacture the right kind of thing. You trust it to play the role you expect, and just send it the message, and everything gets easier. Dependencies disappear, and your application becomes a box of pluggable parts where you can just interchange things. Find the message. Look for the message first. Make up the object if you have to. It may be that you will have no place to send that message. Just make something up and then send the message to that object. Object-oriented design is not in the business of dictating perfection. It doesn't care. It knows there's no such thing. We are practical people. This only request is that you remove dependence and dependencies from your programming sense, that you make self-contained messages and hide behind stable interfaces. Design tells you how to recognize what parts of your code embody meta-knowledge, and it tells you what to do to organize it. So there we go. I'm almost done. So design, like I know this summer, I'm sort of in the middle of, well, I wouldn't say middle, but I'm very interested in the very large discussion that's going on about how much we should apply the principles of object-oriented design to our work in Ruby right now. And it's interesting that some people that I consider very good programmers seem very good at design. And I think I know why. I have an opinion about why that is. I think that if you write object-oriented code for long enough, you don't have to make any effort to learn these principles. The act of writing code will teach you these things. You figure out what hurt, like every good programmer. Eventually you figure out what things hurt over and over again, and you find a way to cook them. That's design. The reason I'm not an academic, and I have to confess to you that I lived in a cave for a long time and wrote object-oriented code all by myself. And in that cave, I independently discovered many of the rules of object-oriented design. And while that experience was valuable, today I can tell you that much of it was pointless. It was too hard. It did not need to be as hard as it was. For example, I'll give you two examples. There was a time when I thought that I had made up the log dinner. I did. I was having a rant. It was even worse than that. I was having a rant with a friend of mine who knew me, and I was like, that thing when you send a message to like gods, get the year too, but I couldn't even talk about it because I didn't have a name for it. And so I did this, I ranted long enough so that she finally understood, and she said, you mean the log dinner? And I was like, what? And she was like, yeah, the log dinner. And I'm like, it has a name? The second story, somebody named TJ Stankins. I was pairing with TJ when I independently reinvented a null object pattern. I think Lori was there that day, right? I was like, if we just had an object that would just answer everything, right? Like those things are hard, and I suffered a lot of pain before I figured out how to do it better. They say that good judgment comes from experience, and unfortunately, experience comes from bad judgment. And I have a lot of experience, but I walked into the headline for a long time, not realizing that there's an easier way. You might be different, but no matter how special you are, there's no need to suffer. We can learn from those who have gone before. Object-oriented design says stability is relative, and you should notice it and depend on things that are more stable than you are. It says that what you want is more stable than what they do. What they do is messy and uncertain and changeable, but from the outside, from where I stand, it does not matter what's inside this house. If you arrange the code so that you cannot see the mess, it does not exist. We stand on the shoulders of giants. Martin Fowler, Kent Beck, Ward Cunningham. We truly do. We are lucky to live in an age of information where the best thoughts of anyone are available to everyone. Now, I'm not saying that any of us in here is one of those guys, but you have to start something. We start out as infants, but you can grow, you can learn, and we can teach each other. It's not always easy. There's no guarantee that you'll be happy every step of the way. But if you persevere, if you learn something about design, that time will come when your applications bring you knowledge. If you learn the principles of object-oriented design, you can use them and write applications that you'll love forever. So, questions?
So in your example, you effectively reconstruct access to a given type based on the string that's passed in. Why don't you just inject the type in the first place?
There are a million ways.
What was the question?
Oh, sorry. He wanted to know why didn't I just inject the type? That's called control coupling, the doing what I did instead of right.
Or dependency injection.
Well, the control coupling is just like, so let me back up and explain. So the question he asked was, someone knows the type out in the real world, right? Like there's somebody passed that type in and I used a factory to construct a class. He asked why I didn't just construct the class on the outside, the guy who did the type. Why didn't I move the decision about what class to use further back to the point where the object that did that type? It's perfectly valid to do that, and you absolutely can. Like I can make up a scenario where this is the only way to do it. It might be that I have a separate factory object. It might be that more information is coming from two different sources, so the original guy doesn't know. But it isn't. Your point is well made. There's a anti-pattern called control coupling, which is the one where you inject something in and make decisions about it later when you could have just gotten the right object to begin with and injected that. And that's a very valid, it's a very valid alternative to this. Absolutely. Oh, wait, here's something. I hate deciding who gets a book, but tonight the first question. Yeah!
David's book was good.
So, we watched your talk a while ago, and we're working on some code, and had a megamess almost, but it had a dependency in it, right? And so we left it there actually. But I was thinking about how do we get rid of that? And is this a good way to move that dependency, make it an internal dependency on a method in the same class that has an external dependency, or would you break it down and reorganize that?
I mean, my stock answer to every question that involves a lot of code that I can't possibly grok in the present is break things into smaller pieces. And then when you do some of them, right? I mean, this is this, like, now that I'm looking at a lot of other people's code that I'm unfamiliar with, which is a terrifying thing, I really recommend it to you all. Like, here's how I judge code that I don't understand. I do what I call a squint test. So you lean back and you do this, and you look for shape. And then I devise some very, very arbitrary rules for code that involve making things too small. And if you have small classes and have small methods and you inject a few parameters, you're probably going to find that some parts of your mega mess go away and the dependency naturally falls out. So I would just refactor it to the point where that basically I'm saying right? Like pull it out into that. But the fact that the first thing is noticing that it has a dependency, because that's what's going to kill you later. Really understanding that something outside the class you're in is going to have an effect on it.
So back to the first question, those alternative models of dependency injection versus reading the message that came out as a keyword. Is one more testable than the other because the your model hasn't been somewhat hard-coded?
And this example, like every example, the 30-minute talk example, there are many different ways to do this. Like I don't tend to put a factory inside a method in a class that uses the resulting object. Like I tend to make factories separate objects of their own, and then I can use them any way I want, right? I can get the object before I can inject them. Like this would be due more leaning up for me. I use a lot of dependency injection. I'm a big fan of it, despite the recent fights about dependency injection. I mean, again, this guy's like I truly believe that. I believe in everyone's good intentions, and what I would tell you about here's the deal. There are people out there who are telling me don't learn OOD because it's all bad, right? But then they're saying don't learn object-oriented design, don't do dependency injections. If anybody kept up with it, there was a very big fight in the blogosphere about this. Here's the deal. If your code, if your velocity, if you are maintaining velocity, keep on doing what you're doing. If your apps, if you're finding it harder and harder to make changes, and you're finding that the changes, a simple changes cascading throughout your application. The people who are telling you don't learn anything about design, they're not really offering much help, are they? I can tell you that these techniques will solve that problem. And so if you've either been in a cave like I was and you're writing code, if you're writing code that's not costing you money, keep on doing it. But if you're in a situation where you're having trouble with some of your Rails apps, understanding these principles and applying them judiciously can really help you out. So yeah, I would use, here I would probably prefer to use dependency injection.
This is a minuscule question, but it just, in 193, I discovered that just passing the name of the type in and then saying, having that variable that contains that, passed in, just saying not new, creates the object. Where 1.8 it didn't.
How cool is that? Did everybody hear that? You said passing a string and saying new to it.
It's a string, or I can't remember whether I make a symbol or a string, but then I just pass it in with not new.
So, I mean, here's the deal. Well, first of all, this
And it didn't
reveals,
work in 1.8.
this reveals that I don't really give it a try. So here's the thing. Like the problem, like lots of people say, oh, the objection I hear very often to rearranging code, pushing code more along the scale of abstraction is that people don't want to have a lot of little classes. That's what they say. I'll have a lot of little classes, right? And one of the things that happens to people who came to Ruby through Rails is that it's easy to never have really quite grasped how the files get loaded off disk and turned into objects. And since the Rails will do that automatically for you if you put every class in a file name in a certain place by it, right? So you end up with this huge proliferation of tiny little files, which I know is totally crazy. And so, so the only thing I'll say about that for Rails programmers now is you don't have to do that. You don't have to put every class in a file by itself. But the second thing I'll say is, so what? I don't really care what the class of an object is. And here's the thing. Why not? Because I'm really comfortable with it. That's all. Just because I got used to it. And it's just like everything else you've ever learned. Like you buy a new keyboard, when I bought the Aragon keyboard because I'm a woman of a certain age, I just cussed it because I couldn't type. You know, Vim is still making me crazy after like 3 months. But we'll get better at all these things. Like every leap we make into new territory involves a leap of faith. When I started testing, when I first started doing TDD, I so sucked at it. And if I had judged whether or not all those people that seemed really smart were right about it, based on my experience, I would have rejected it out of hand. And so it's not really me that's telling you this. I mean, I think that there are plenty of really smart people. Like, I'm a translator, and that's all. I'm not really making up new ideas here. But there are people who've spent many years writing object-oriented code, and they do kind of get it. They get what costs money. And so, for me, I would tell you that they don't care that there are lots of classes, because it doesn't really matter, and that you too will be used to that. So the first thing is, like, you don't have to put it in many little files, but even if you do, I don't care. You'll get over it. I mean, you get in apps that have lots and lots of tiny objects, you're completely reliant on your test to run. The tests are easy to write, but very, very often it is true that you can't look at any one place and see the operation of it. And that's scary. I'm very sympathetic with how scary it is, but all I can tell you is you'll get used to it. And the apps are easy to change and maintain once you do that. So more questions?
Yeah, so on that note, even this afternoon I was doing some refactoring, and I had a senior developer come over and tell me, you're making a lot of little files, right? So on that point, do you know why? Like, have you received any, have you discovered any empathy for people? Like what is the fear?
I think it's that skill, right? Like it's easier to talk about if you push it all the way, push the examples all the way to the margins, right? So on the one hand, my entire app can be one long script. And on the other hand, I can put every method in it. I can put one-line methods in single method objects, right?
Those are both wrong answers.
Those are wrong answers. That gives you sort of a range, right? And there's a place, and what we're trying to do is we're trying to maximize our ability to understand the app, and while at the same time maximizing our ability to easily make change. And those things are lines that cross. and they cross somewhere on that scale. The thing I would tell you, and here's the thing, because we're all like a little bit too clever for our your movement in the direction of more smaller objects, you should probably stop. You should probably get off that train one stop before your inclination reaching, right? Don't do that last refactoring. Don't do it until you have clear evidence that it's costing you money. It's very often true that the last refactor, the one that completely dries the code out, is also the one that makes it absolutely incomprehensible. Right? And so, I don't, it's okay with, like, the one thing that's happening, like now the older I get, and it helps being older, right? It helps that I've been doing this longer, because I'm much more comfortable with leaving messes. I'm much more comfortable with the fear that I might get criticized because something's not perfect. And so, right? And so those of you who are younger, you probably feel like you're gonna leave a mess in your code and people are gonna be critical. Like I have checks of private methods, check-ins or repositories and where I have a little note that says, if these start costing you money, leave them. Like I break these rules all the time. But I break them in ways that, because I'm trying to optimize for clarity and saving money in the present, and I'm constantly trying to wait on more information. And being able to wait on more information very often means leaving a mess. Or like maybe you think you're going to have a hierarchy and you have 2 instances of it now, and you don't really you want more information, so you're going to leave 2 almost duplicate classes with a little note that says, this looks just like that. Go make another one. Wait on information, right? Like feel comfortable doing that. And if people get on you for this, and
of course, you know, the standard sort of when people say, "Oh, no, it's it," you just go, "Yeah."
Yeah. I mean, Yangi is being used right now as an excuse to not do design, and that is a complete. That is completely anti the spirit of Yangi, right? Like my definition of design is how you arrange the code on this.
So for those who don't know,
oh, sorry.
You
aren't gonna need it, right?
Yangi.
Hey, we're in the South.
We're in the South. You ain't gonna need it. Yeah, so people will tell you, oh, I need to do design because I'm agile and we're iterative and agile and we're putting new stuff, throwing new code, we're blah, blah, blah. So here's what I would say. Like, if you want to throw your code away during every iteration and rewrite it all, don't think about arranging your code so that it's easy to change. Like, that's what the principles of object-oriented design say. We're not talking about making speculative requirements. There was nothing in this code example that introduced code that it was for a feature that isn't currently being used. And that's the rule I have, right? All the code better be being used for features I have right now. The speculative rearrangements of code that allow something new to happen in the future, they almost always turn out bad. It's a waste of time and money to do that. However, understanding the tools of it, and that, like every time you arrange code like this, you're making choices that have consequences. And if you don't know the consequences of the choices that you're making, it doesn't mean that there aren't consequences. It just means you don't know. And so the food gives you lots of different ways to choose how to arrange the code to solve any problem, and it predicts the consequences of each arrangement. And so if you know these rules, you can choose where you want to lean. I'm an advocate, can you tell? I love it. So who else? More questions? I hear there's a place.
Yeah, you talked a lot about the relative stability of different things, and there's some really obvious examples like implementation versus the name of the message. What are some other guidelines for determining what is relatively more stable than another thing?
It's those things where, here. In general, in your app, I can give you some big rules. Like in your app, the core of your domain, especially for a new app that you're writing, the objects at the core of your domain are probably less stable than the objects on the edges. And I say that just because you probably don't really know what business you're in until you get some software out and start using it. And so the things that tend to shift, that get a lot of pressure to be flexibly changeable, tend to be the objects that you think think of as being in the core of their name. And that suggests that they should pick, well, so that's one thing. The next thing is this whole notion, the solid principles is interface, whatever it is. Like you should, if you depend on the role instead of the class. So let me specifically say that. The name of the cost method in this example was very stable. The names of the different classes were completely undependent. And so thinking of yourself as depending on the message rather than depending on the class lets you depend on something that's more stable. Like the message is likely going to be more stable. So if you use sequence diagrams, when you sit down, what you're constructing is APIs. You're saying these people are going to talk, these objects are going to talk to each other across this interface, and whoever's on the other side will just do it. So the objects at the center of your domain are probably more unstable. The classes are less stable than the messages. There's one more thing I was going to tell you. Oh, and so there's a design technique, the loosening coupling is a way to deal with uncertainty. Like if you know, if I have like string is a great example. Does anybody tell you to inject the string class in classes? No. It seems ridiculous, doesn't it? The thoughts of injecting a string, but think about it for a minute. Why not? It's a class just like all the others. We don't inject strings because we completely trust them never to change. Right? That class is so stable that it never occurs to us that we might want to inject that dependency. And so sometimes it's very clear that one object is more stable than another, in which case you can't depend on it. Sometimes it's very clear that the role is more stable, in which case you can't depend on it. Sometimes you just don't know, and very often the things that you really don't know about are the two objects at the center of the domain. And probably all the other Rails apps where you got that wrong, and the changes cascade back and forth between those objects. And so there's a way to loosen the coupling between them. I'll talk to you about that. That you should do. Like you should look for those. Like those two. Like maybe your app has 100 classes. There are probably 2 or 3 classes in every app that you should spend a fair amount of time thinking about how to get them to communicate in a decoupled way, because you don't know what's going to happen to them, but you know they're going to change. And that's what makes your those are the classes that make you hate your app.
So I was actually going to go ahead and wrap it up since we've hit about 8 o'clock. I think Sandy, you said you were.
Let's go over here.
Yeah, Sandy said she's going to be going to Sammy's. So I mean, we can continue the questioning afterwards. I'm sure a few people will want to Sammy's, but there's so many people here. I don't think that they know how much people will be on the way, but we'll just play that one however it goes. But anyway, can I get one more round of applause for Sandy?